Okay, sir.
Okay, a double pane, very popular. Double glaze,
Sir,
double pane.
one more thing, sir. 2020, right?
Ah,
Those last year batch, right? They are very lucky, you know. See, I told you, right, sir, chapter 9 to 11, they like to ask one section B or C confirm, right? I told you before. It turns out 2020 section C, chapter 11 came out, and then section B or C, chapter 10 came out. No, section B, chapter 10 come out. So
yeah.
whoever really studied chapter 9 to 11, section B and C is a bonus already.
Okay, so a double pane window has a thin layer of airtight seal between two planes of glass, right? Two planes of glass, air in between, which is often used to minimize the transmission of heat through the glass plane. Explain the mechanism of heat conduction through the double pane window. Right? Heat is transferred from outer glass plane through the thin air layer and through the inside pane to the room. Why is a layer of air must be very thin? Right? Thin layer allow convection. Sorry, thin layer reduce convection. Right? Remember, you stop it, you don't allow it, you do not allow the air to go out. So it's confined to a thin layer. Must be thin to reduce convection in the air and heat loss by convection. Okay with that?
Just a minute, sir. So, sir, that means chapter 9 to 11, I studied thoroughly, sir, basically.
Chapter 9, then usually will come out one question one.
Yeah, no, section B, section C, I noticed, right, sir, 2019,
Yeah,
2020.
you study, that's
keep
why
on asking.
they write it for you. What are the places you have to emphasize on? That's why the
So
book.
chapter 10, 11, like this the extremely important one. Like 9 to 11, like I scored this properly, right? Section B, C, like a bit, like I'll get the marks I needed.
Yeah, you have to be patient and learn to read. Don't just simply give up, see, cannot answer. Think through slowly and read through slowly and say, I can do it. I have the confidence, not just give up.
Yeah, the B, right? Sir, your answer a bit confusing, sir.
Quite confusing.
The layer of air must be thin to reduce convection in the in the what? Sir?
Oh, sorry. The layer of air must be thin to reduce convection in the air. Sorry. And heat loss by convection. Basically, the air becomes an insulator. Okay. What am I doing? Can't spell properly as well. A double pane window. Yeah. Area is given. Thickness given. Thickness of the glass. Thickness of the air. You can see very thin. Very thin. If the temperature difference is also given. Okay. So you have in mind what is happening. This is your double glazed window. There's your air inside there. Temperature C theta. Right? Use the formula. Very popular. Don't worry about negative sign there. So always take it from the hot side, higher temperature side, which is theta. And start with here, this formula. Start with the air. That formula. Start with this one. Right? K1 B minus C divided by L1. L1 is this one. Right? These two are L1, the same length. And put in your value. Your theta. There's your theta. There's your C. There's your A. Okay. So put in all the value there. Then solve it. Right? You can solve with these two together.
Or cross multiplication.
Cross multiply, that's all. Right? Cross multiply. And then solve it out. That one minus 40A take to the other side is 41. 41A minus B equals to 40 times 35. You get this answer. And then the next one is use these two. These two together. Doesn't matter if you can use these two also if you want to. Right? Whichever is easier. If you use these two, it's easier because they cancel off. The A cancel off, the L cancel off.
Because it's over forward.
You want everything simpler. Right? Second equation. Then you add the two equations. 41A plus A is 42A. This one, you plus a 2. So this one plus that is 1455. Okay. Calculator, use that. Right? One decimal point enough already, but the following calculation may need you to have probably
To be
about
more
five
specific.
significant figure, more significant figure.
Oh, one more thing, right? Like chemistry, right? For example, like sometimes I don't like it because they always like to emphasize on the significant figure, depending on the question. Even though answer correct, right? But significant figure or decimal wrong, right? That's it. Finish.
Yeah, chemistry you have
Physics
to be
also
careful.
strict.
If your teacher teach you that way, you have to follow the significant figure. Physics,
No,
you have to
but
roughly the
physics,
answer is about 2 or 3, that's all. Right? Because
but they are not strict about that, right? That's why I'm
not that
scared now.
strict, but your answer may be slightly different if you round off too fast.
Oh yeah, so
You
like
can see my
just
answer
like
and the answer is slightly different, but it's just a matter of significance.
just no difference lah.
So that's why I work with 5 lor. Then round it off to 3 lor. You can put with 4 if you want to.
Okay.
Determine the percentage reduction in the rate of heat flow by the double pane window compared single pane. So you calculate the single pane. No? That's your single pane. One side only. This is the 35. This is 20. And that is your A. This is your K. That's your temperature. 35 minus 20. That's your length. Change it to meter. Right? Percentage reduction. That's a single pane minus double glaze divided by the original. Without double glaze. And you get 97.6% or 98%. Okay.
Okay.
Yeah, I can see that conduction is most popular one. It's practically like almost every year will come out. Describe two mechanisms for thermal conduction in metal. Yeah, what two mechanism? Yep. What are the two mechanism?
Two mechanism.
Two method of heat transfer by conduction. Yep. Not ready. First, hot end there, greater vibration of ions, greater amplitude. So the wave travel to the cold end. That's one method. And then the other one is the electrons at the hot end have greater kinetic energy. So it diffuses the cold end where the electron have a lower kinetic energy. So that's how the heat is transferred. Then write down the expression. There's 2 mark there. So you must tell them what is the symbol stand for. That's the other mark there. State 2 condition for the expression B1 to be valid. Thermal conductivity is constant, doesn't depend on temperature. And then steady state has been reached in the material. Okay.
Yeah, teacher. Full screen.
Look at the mark and then see what are the points you have to. If 2 mark, 2 points.
Yeah, it's 2 mark lah.
2 marks means 2 points, 2 clear
Wait,
points.
usually when they mean write an expression means what do they mean? I don't understand that part.
Equation, write the equation. The formula. Write the formula.
Oh, okay.
Right? This is a simple point to get. Again, they make it harder and harder. So first is memory work. Memorize the formula. Right? You may have to define your dq/dt, rate of heat flow. This one, rate of heat flow. Okay.
Okay, next one.
Sketch the graph of temperature gradient against distance from the joint rod. Which rod is better thermal conductor? Explain your answer. So this one 5 marks means you have to do a bit of calculation. No? Right? That's your temperature gradient for P. That's why they give you the value. Right? You want to have certain value, you must put in there. You want to see your graph is properly drawn. And then for Q, same thing, 25 and 0. Right? That's your length there, change to meter. Right? So the value must be written there. And K is inversely proportional to temperature gradient. Okay, so roughly that will guide you where the value should be written. And then they ask you explain your answer. Right? Explain your answer. Your K is inversely proportional to temperature gradient.
Oh, the green one is the number 4 one, right?
This one is number 3. You have to calculate this one first before you can draw this graph.
Oh yeah, I mean cannot simply. I mean we'll get mark for the calculation.
This is 5 mark, 5 mark means they want you to calculate.
Oh yeah. You cannot simply sketch one. And then have to tell which one is better thermal conductor. That one 1 mark, and then sketching is like 2 mark. Calculating is 2 marks, something like that lah.
Calculation, the graph itself will be 2 mark, I think, no, with the value there, and then the right proportion, roughly the right scale.
Yeah, and then which rod itself 1 mark, calculation 2 mark, graph 2 mark lah. Wow. Okay, the next one.
So temperature gradient of Q is smaller than P. Thus, Q has a better thermal conductivity. Okay. Always refer back to the formula. Where's the formula? Right. Always refer back to this formula. What am I doing? Right. That's the reason why they ask you, because they want you to apply that. What is happening? Happening. Okay, always refer back to that in your explanation. Your for the same rod there like that, this one is constant. So that determines your temperature gradient. Your A is a constant, so it's K and d theta dx. That's all. These two can change because of the different value of these two. That's all. That's how we are saying here. Okay, yeah, from here, your A is constant, dq dt is constant. So K and d theta dx are inversely proportional. That's what this means here.
Yeah, okay, sir.
Right. Then after that, calculation. Remember your temperature gradient. Right? We have calculated that. And use this formula. Right? Your dq dt is the same. Right? Don't bother about negative sign there. Right? I just changed it to G, that's all. Then cross multiply, take the KQ down, A cancel off, take the GP down, and put in your value. You have already calculated here and here. Okay with that?
Actually, go back again. Okay.
Okay.
Yeah, okay. Yeah.
Explain the mechanism. You can see there the first question is explain the mechanism. Right? Free electrons. Free electrons at the hot end there have more kinetic energy. So it diffuse the cold end. And then the vibration at the hot end is greater amplitude. So the waves travel to the cold end. Then after that, you are given a part of the brick wall of a house is shown
Did I go back again?
in the diagram below. Wait. The wall consists of 2 layers of brick in which each layer is 10 cm, right? 10 cm, 10 cm, so it's 20. The outside is 34, that's the outside. That's the inside. Thermal conductivity is given. Calculate the rate of heat conduction per unit area through the wall. Right? So write out the formula, then see what they want. Rewrite the formula. They want your calculating the x value where we call dq dt over a. So then take the a down, you get your minus k d theta dx. So put in your value. Okay, that's your value. That's your 34. That's your 22 here. And then 20 cm converted to meter. That's your value that they want. Okay.
Okay, sir. The left side is A, the right side is B, right? Sure.
Yeah.
Okay. Next one then, sir.
So my computer is giving me problem. Doesn't like the thing I'm doing. Okay, so we have calculated part B. The brick wall in B is separated by air space with thickness of the thickness of your air space 5 cm. Thermal conductivity of air is given. Determine the percentage change in the rate of heat conduction per unit area compared to B. So calculate again, no? Right? There's your value for just now, your part B. Theta 1, right? We have calculated that. Theta 2, we have calculated that. Then I want to calculate Lx1, dq dt over A. So that becomes your minus K, refer to the previous one, minus K d theta dx. So calculate your X1, 0.8, and then 34 minus that one there. Get this value, percentage reduction, right? That's the original one, minus the reduction, divided by original. Can?
Wait, Acha.
Actually, you cannot do this question first. You have to do part two first. Determine your
Part
theta
2.
and theta 2. Okay? Unless you use the formula given in your textbook, which I don't think I want to teach you that. Unnecessary formula to learn. So you have to calculate your second one first. Okay not? Okay not?
Where's the this one, Je?
You have to calculate this one first. This one.
No, I can't see your this one.
Oh, sorry. Sorry. What am I doing? Okay, that's your number 2. In case you are not able to see previously, that's your first part of calculation.
Yep.
Can?
Can, okay. Next one.
And this one you have to you cannot unless you use formula which I didn't teach you. Then you can calculate one first, but this one you have to calculate 2 first. I calculate theta 1 and theta 2 first. So that's what I do here. Right, use this formula, assuming the rate of the heat flow is the same to this layer of glass, this layer of air, and this layer of glass. And form your formula for this layer. 34 minus theta 1. Your length changes to meter. That's your area A. And then for this L here, right, conductivity is given there. And then there's your theta 1 minus theta 2. Change that 5 cm to meter. There's that there. Then this layer of glass. Right? 0.8 is your K area, is not given, so we just put it as A and theta 2. Right? So same as what we did before, just form the two equations. So take these two, form an equation, simplify it, that's your equation 1. Then take these two, these two where you can cancel common factor off, make it simpler. So you got 34 equals to that one. Then simplify it, equation 2. So you just add the two equations to carry your theta 2. So this 18.39 plus 1 here, 19.39, 56 plus that value. Calculate your theta 1. After that, calculate your theta 2. Yeah.
I think C1, right? You missed it out already. They put that as percentage
I
change.
know. That's why I told you you have to do 2 first. Unless you use the formula given in your book. I didn't use the formula. So I have to calculate my theta 1 and theta 2 first.
Okay. This one
Right?
is number
I do
2
part
then
2
lah.
first. I do part 2 first. Without part 2, I
Alright.
cannot do part 1. Right? Your model answer give you using formula, which I don't think is unnecessary complex as all. Unnecessary formula to remember. You can use that if you want to.
Okay.
Right? Then you can, after you do that, then you can go to this one. Right? That's why this is all that we have calculated. Then you can calculate your x1. One layer of that there. Then put in your value for x1. Right? New value for x. Just now we calculate x. Now we calculate for x1.
Oh, now it's the reduction lah. Oh, they purposely did it in such a way where you have to do 2 and 3 first, then only 1 lah.
Sometimes you have to do the second one first. Unless, as I say, you use the formula given in your book. Then you can do 1 first. To me, it's unnecessary formula to memorize. That's why I didn't teach you.
Oh, okay. Yeah, okay, Chair, can go on.
Okay, this one we have done already. Then sketch a label graph to show how the temperature across the wall, outside and inside. Right? 3 mark means they want you to draw it, sketch with value that you have calculated. So you have to show your value and show the proportion. This one is very small. This one is very small. That's how you draw. Right? All the different values must be in roughly the right scale. Roughly the right scale. Why is polystyrene shade a better alternative compared to air, although polystyrene has the same thermal conductivity as air? Air expands with temperature, thus increasing the air pressure. Polystyrene is solid, thus help to, okay, we have to finish in a while. Polystyrene is solid, thus help to make the brick wall stronger. Okay. Air also, if you put polystyrene, there's no convection. Air, there can be a little bit of convection. Okay.
Hey, what you say about air just now?
Air, you have a bit of convection. Depend on the
air has a bit of convection lah. Okay. I think I know what to study already lah, but it's risky lah. I know I have to study everything. But if you notice, right, 2019, 2020, they like to ask C9, 10, 11 a lot.
Just go
So I'm going
the
to
question, then
study.
you do the question,
Yeah,
then can
C9,
roughly
10,
spot what
11.
are the area they are likely to test you on.
No, section B and C, I already noticed lectures. C9, C10, C11, they always regularly ask. They cannot skip this one for sure. Confirm they'll ask
Production
one.
is the most one because there's a lot of formula to calculate.
So I already have my bonus mark already. I already know like what going to come out. So I'm going to
Good.
study that
Good.
thoroughly,
As
do
long
more
as you
questions.
know what is coming out, can guess roughly what is coming out.
I mean, teacher never told me. I guess myself already because I look at that already. I know the teacher the way they ask. But the other chapter, I'm not sure lah.
Okay, looks like we have to stop here.
Okay,
You
okay.
need a class
Thank you.
tomorrow or no need?
Tomorrow, I thought teacher say leave what?
You want a class? 2-hour class.
I'll confirm to you. No. If 2 hour means usually I prefer 1 hour lah. 2 hour then I headache. Cannot focus.
Okay.
But then usually teacher say Sunday you leave what?
Not tomorrow, Monday.
No. Usually Sunday only you say teacher will be leave what? Holiday. Yeah.
Usually Sunday I don't want to do any work.
Yeah, but then teacher telling class tomorrow can?
Tomorrow I mean Monday, not tomorrow. Okay? God silap, make mistake.
Okay.
So you want a class? Monday, let me know.
Okay, I'll let you know, Sir. Okay, thank you, Sir.
Okay, bye-bye.
Bye-bye. Have a good day, Sir.
Okay, have a good day then. Bye-bye.
Bye-bye.